Stephen, and I see the recording. So we are good to get started.
Sorry about that. Took a bit, but we're there.
Yep, we're there.
Good.
Okay, so LibVCX was originally conceived as a layer above libIndy that would be, I'm not sure the right way of phrasing this. It was meant to be a layer of abstraction above libIndy. It was not meant to cover everything that libIndy does. It was meant to cover a subsection or a subset of everything that libIndy does, but make it basically zero in on a particular set of use cases related to claims exchange and operating with an agency, operating specifically with the Evernym agency that was also being created at the same time. So it would do some of the thing. It would basically make certain calls out to libIndy, but it wasn't exposing all of the libIndy functionality. It was only exposing a subset of the things related to claims exchange. So for example, creating DIDs, creating credential offers, credential requests, and credentials themselves, and then doing proofs as well. But definitely in a way that was easy for sites to onboard and in kind of an object-oriented model. So LibVCX has, I would say, I think there were 5 main objects. The first is a connection object that is used to create a connection between originally it was between an enterprise and a consumer. But that can be abstracted to basically be between any 2 entities that want to connect. So you have this connection object that goes through and talks with the agency then sends out, for example, an SMS to the receiving party, or it could just return back invite details that could be displayed as a QR code. Then from the text message or the QR code, a connection could be established, a secure connection, authenticated and encrypted between the 2 parties. Then from there were credentials, but credentials have 2 different sides, and so there's 2 different objects. The first is the side that is issuing credentials, and so we call that an issuer credential. And then the other side is the credential object, that which is received by, in most use cases, the consumer, for example, a credential offer is received, a credential request is sent, and then the credential is received. And then on top of that, we have the proof, and we have the proof requester, that's the proof, and then the disclosed proof, and that's on the consumer side, the one who discloses their own proof. So let's go through those objects again. Connection, issuer credential, proof, and disclosed proof. So those were the main objects that were initially conceived. And at first, this was going to be an enterprise-only thing, but then it was decided, well, let's have LibVCX handle both sides. And so at that point, the consumer sides of the interactions were added. The credential and the disclosed proof were added later on. In addition to those, as helper functions, as helper routines, it was decided that there was going to be some rudimentary schema and credential definition support added to LibVCX. These were not meant to handle all of the different use cases, but they were meant to handle some of the more basic use cases for creating schemas and for creating credential definitions, and then utilizing those when sending out or when issuing credentials. So in addition to those first 5, there's also the schema and the credential def. Now, it is fully recognized that a lot of these things are available within libindy, but it was never meant to be the case that LibVCX was meant to sit a layer above, to be an abstraction, and to basically make it a little more user-friendly. Maybe that's not the right word. User-friendly isn't the right word, but basically it was meant to abstract away a lot of the complications and a lot of the complexity and make it so that sites could get off the ground quickly and integrate this functionality into their existing workflows. So it is a simplification by design over the complexity of Indy SDK, or libindy, I should say.
But could you provide some examples of simplification? Because as I understand, VCX provides exactly the same credential exchange protocol as libindy provides. So it uses exactly the same messages and
So basically what it does is it lets you, you don't have to, what's the right way of saying this? I'm trying to think. It's meant to be that when you create a credential, it is for when you are interacting with a connection. So all of this is based around connections or handing it out. So the idea is that when you create the connection first, and then from there you do things with that connection. So you create a connection and you get a connection handle. And that handle is how you then, with that connection handle, you then say, okay, now I want to issue a credential to this handle. And so you give it the details of that credential, and LibVCX will automatically handle the sending of the credential, the offer. So for example, there is no need to specifically say, okay, create this offer and now send this offer. Basically what you do is you create it with specific details, but you don't have to store the offer and handle it. You store the credential, the issuer credential object. So it encapsulates the outputs of Indy SDK from the various libindy calls into a single object. And then from that object, you do actions on that object without having to store the outputs and things of that nature. So that would be the simplification, is that you're just dealing with an object. You can serialize that object at any point in time, but you don't and you shouldn't necessarily look into that object. You just serialize it and deserialize it as needed. And you marshal it through the different stages of its life cycle. So create, send the offer, check the status of it, and if a request has been received, then at that point you send the actual credential without having to manage the inputs and outputs of the specific libindy calls.
So another view of the answer to that question is that at BC Gov or the Canadian group that are working on this, we built Bon Anchor, which I would have described pretty much exactly the way Doug described LibVCX, an object-oriented layer that simplifies the sequences of libindy calls that have to be made to carry out certain operations at a higher level. So it's pretty interesting the way he described that to me, because we built the exact same thing, and we hope no one else has to, you know, the idea was that we'd have one developer focus on that and provide those services to everyone else who was working on things. So, yeah, and have similar objects. We've gone a lot further in handling things like schemas and cred defs.
And you also have revocation support.
Handle more. Yeah, that's what I mean. Revocation support, a lot of caching support. We discovered there was a lot of, obviously, every time you get a transaction, you go back to the ledger to find out what's going on. So we added a bunch of caching support and things like that to really improve the performance of it and things. Ours is written in Python, which is a problem because it's not generally usable. But just in answer to Slava's question, that's the reason for it. Is once you start to look at this, you go, oh, well, when I want to issue a credential, I've got to do a whole bunch of things in order to issue that, a whole sequence of calls. And rather than everyone figuring out what that sequence is, we wanted to have a single mechanism to call to issue a credential, and so that the issuer code needs only worry about, okay, what schema are you going to use and how are you going to stuff data elements into the claims and then trigger the send. We don't want to worry about all the sequences underneath to figure out how that happens. So that's basically the reasoning behind the model, behind the implementation.
Yeah, so it sounds like there were the same goals between Bond Anchor and the LibVCX project, which Stephen, you and I have discussed. So that's really the layer of simplification, is just kind of abstracting, just like Stephen said, abstracting the sequence of calls, the inputs and outputs between them, and making it hopefully easier for organizations, institutions to get off the ground and up and running without having to become familiar with all of these, and just doing it at a higher level. So does that answer your question, Slava?
Yes, I believe it answered my question.
Okay, so with that,
But I have one additional question. If
okay.
You think that this simplification is important, maybe we can consider to enhance interface of libindy.
Well, I think that's the point of putting LibVCX into Indy SDK is, yeah, you're actually putting a layer on top of another layer on top of libindy. You want to still expose libindy, but the vast majority of people would be expected to use the higher level abstraction.
And not only that, we've actually seen some use cases here at Evernym where people are wanting to do some very, I would say, maybe corner cases that require that kind of fine-grained access to libindy, and we have pushed back and said, yeah, this isn't a use case that LibVCX was intended to support. We don't plan on supporting this kind of a use case through LibVCX. And so at that point, we have pushed them to libindy, and they were able to do what they needed with libindy, because libindy provides a lot more flexibility. But as is almost always the trade-off with software, when you have increased flexibility, you have increased complexity. And there are some sites, there are some organizations that need that kind of flexibility because they are doing complex things. But the higher levels necessarily provide that kind of flexibility, and therefore are less complex. And I think Stephen is right that that was the idea of getting the LibVCX into the Indy SDK, so that sites that are not planning on doing these complex kind of workflows and handling the complex use cases have a simpler API to use for their simple use cases. Okay, so are there any other questions so far?
How mature is the LibVCX in your opinion?
So, in my opinion, it is quite mature for the use cases and the platforms that it supports as of today. So, as Slava has mentioned, there are use cases, there are things that you can do with libindy that you cannot do with LibVCX. And so considering the narrower use cases, I believe it is quite mature within that realm. Now, one of the things that needs to be stated from the very beginning is that LibVCX was designed to work with the Evernym agency. It was designed to work in conjunction, and as of right now, it is closely tied and it is dependent on that agency being up and running and speaking the protocol that LibVCX was designed to speak. So these two, the LibVCX and the Evernym agency, have been brought up together and are closely coupled. Now, there is an effort underway right now to take the agency or the agent functionality out of the Evernym agency and open source that. And that work is being done right now. And as that happens, as that unfolds, then that same functionality will also be put into LibVCX so that LibVCX can then speak with this open sourced agent that is being worked on. But as of right now, that work is not done. It is ongoing as we speak.
Thank you.
Any other questions at this point?
So I'm seeing some people, this is just out of interest, but I'm seeing some people trying to run the BTX code in the community. Given that it's tied to the agency, are they going to have any luck?
Well, as of right now, I think the short answer is probably no.
Okay.
As far as like actually running it from an end-to-end use case where you have two instances set up that are communicating with each other, the only way to do that is with an agency in the middle.
Okay. So I don't know who those people are, but I would hope somebody at Evernym is staying on top of that and sort of guiding them a little. Just
Yes.
because, yeah, you wouldn't want them going too far down the line.
I understand it. Richard is acutely aware of this, and and there are engineers. I'm just sorry. I'm looking right now. I think he's on this call, but there are engineers now who are working on that, open sourcing the agent and getting it so that LibVCX can work on it. So they're aware. They just it. Yeah, it was one of those things where it needed to get out there in the open so that the community could start looking at it, but not necessarily using it.
I would also add to this that we're having some struggles in the standards process where instead of working from something that's a functional implementation, we're doing a lot of kind of guessing our way through how things should work. And we're really desperate for, kind of a reference that works that we can then modify to get it to where we want it to be. And I think that the agent messaging in VCX is probably the thing that we have that looks like that. So the sooner we can get to where that's part of what people are playing with, the faster that specification will progress. And I also have mentioned that in relation to our validation of how some of the processes work for the next couple of releases, we're missing some of the pieces that VCX provides. And so we either have to make it so VCX works from a community perspective, or we have to basically re-engineer or invent some reference code that would hopefully work the same way that VCX works. And so I know that Adam has been trying to figure out how to make it so that, for instance, we can complete the credentials exchange use cases without the Evernym products to show that the open source protocol is complete that are related to that.
The protocol that LibVCX uses to speak with the agency, there's nothing proprietary or secret about any of that. It just isn't necessarily implemented on the other side by any open source aspect. But that protocol that it speaks, where it bundles, it creates a message and then bundles it up and puts it inside of a forward and then sends it, you know, anonymously, encrypts that for some agent on the other side, and that all of that messaging, which today is using message pack, though I don't know if that's going to be the case going forward, but all of that bundling and encrypting, and then on the other side, LibVCX, where it unbundles and decrypts it. I would say at this point that the piece could probably be simplified quite a bit to handle the routing of these or basically to just be a simple agent that collects these messages that LibVCX sends and then makes them available to the other side of LibVCX, which then queries and says, give me all of my messages, and then at that point it just debundles and decrypts all of these messages. But yeah, it's a moving target kind of all around. Nevertheless, back to the original question, I would say that within the scope of the use cases, it is very mature. So any other questions?
Is the agent piece going to be added to LibVCX, or is it a separate library that will sit alongside it?
I believe the agent is going to go into a separate repo and will not be part of the Indy SDK. Does anyone know differently?
Yeah, I mean, can you hear me?
Yes.
So I'm working on outsourcing the agent, and the agent will be just a reference implementation how we can build the runnable agent. So it won't be a library, it won't be a set of methods that you can use to build an agent. It will be just a software component that's using libindy to show you how you can build one. It will be an application.
Okay, so it'll be an application, not a library. Okay. Any other questions?
This is not so much a question, or maybe it is. Based on what we've talked about for how agents communicate and the protocol, you know, that we sort of talked about in Provo, it's my impression that a lot of this is dependent on some features that aren't in Indy or libindy yet. In particular, the ability to have flexible DID docs and basically multiple endpoints, multiple keys, multiple endpoints that are not constrained to be addresses and ports, and the ability as well to have an endpoint being a DID. I think those things are all kind of prerequisites to getting a agent that can talk flexibly. Wondered what's the thought on that, and where others see that priority for building, you know, sort of interoperable agents. And basically the question in this context is LibVCX kind of depends on an agency that's not going to be available to others. So you're trying to remove the dependency on the agency, but is that really going to move it forward from the ability to generically talk to other agents, even without an agency.
I think ideally, the goal is that once the protocol is established, that anybody can implement the protocol, and that LibVCX will be the way to use that agent-to-agent protocol, at least from the edge devices. From it, there are obviously many use cases and a lot of flexibility that could be added to agents and to agencies to allow them to, like you said, multiple endpoints, keys, and all of that. But I think for right now, the focus is on getting something up and operating end-to-end using open source components. And once at least one pathway has been established, that using only open source components, an entire end-to-end credential exchange can be accomplished, then from there, I would imagine that the agents and agencies will be expanded to handle more complex use cases. I don't know if that answers the question, but I see it as, yeah, we want to do all those things that you said, but we're working on we are blazing the first trail, and then once that first trail, once this pathway has been established, then we can at that point pave the road. But right now we're hacking through the jungle.
But I guess my thought is that even to do that, you have to have this more flexible DDoS capability. That's my theory anyway. And I don't know if it's right, but I think in order to do what you're talking about, which is to enable edge agents to talk, you actually have to have this capability. Unless you really, really constrain it down to the simplest of all possible use cases, which is each entity only has one agent that talks directly to another agent. In other words, there's no sort of internal structure. And I think that use case is not
I don't know what you
even
mean by
viable.
no internal structure. Could you explain that?
The idea that a phone talks directly to another phone. So two entities want to talk, and the only way they can talk is if their phones actually communicate directly with one another with no intervening agent, if you will. And I think that's not really viable. I think even for a phone to talk to another, it needs another party. It needs another thing, and again, this is the problem with everything's an agent everywhere, but it needs a cloud agent somewhere to facilitate that conversation. They wouldn't talk directly to one another. They would talk through an intermediary. And even though they're at the application level, they're talking to each other, the messages are being transported through at least a minimal series of other agents along the way.
So the reference agent that NEM is working on, is that reference agent meant to be run on the edge device, NEM, or is that something that's as a service?
So we have two things now. First thing is a reference cloud agent that's going to be a cloud agent as you described it. It will sit somewhere, it will listen for messages, it will do some basic forwarding or routing, but it will be just a basic, proxy. So it will enable a VCX built edge agent to communicate with another LibVCX build agent through you can call it a simplified cloud agent. It won't be an agency, but it will be just a proxy. So that is the first step that we want to do to kind of build the full flow. And we have an edge agent that's now being open sourced. It's called, I think, Sovereign Connector or something like that, but we'll kind of need to make some changes, and that's a reference edge agent that we built in Evernym or with LibVCX, and we will eventually combine the two, so the edge agent and the cloud agent, to demonstrate how the flow and the protocol goes. It won't be the full-fledged community protocol that we talked about at Provo. It'll be some, intermediate kind of showcase of ability and of the infrastructure and architecture, but eventually it will converge to a community protocol where we can say, so this is the protocol, these are the reference agents that implement the agreed upon protocol. If you want to test them with your own agent, you can build them against it, you can run the test suite, you can run the test harness. So that's the idea.
Okay. But I think even for that, and I guess you can work around it, but even for that, you need at least 2 keys and an endpoint.
I think that's true. When you say 2 keys, you mean one for...
So you need an endpoint for the cloud agent,
right,
a key for the cloud agent to be able to just decrypt the message enough to forward it to and then another key at the edge agent to actually decrypt the message. I mean, these are picky, so it doesn't really matter. Yeah, okay. I get your point. I see how you're doing it, Nam, and that makes sense. That makes sense.
Yeah, and the fact that each agent has its own keys and that you don't ever copy keys, that is very important.
Absolutely.
What about it's a kind of a corner case, but where you have 2 edge agents that talk to each other, such as like I have 2 phones, right? One is my old phone, one is my new phone. I'm upgrading and I need to sync data across them. I'm not copying keys, but I am copying other information like contacts or possibly microledger data, credentials over, say, Bluetooth.
Well, and this is where we've started talking in the past about needing a construct for essentially like some sort of group encryption or some sort of proxy re-encryption, so that you have the idea of saying, I'm going to send this to the identity owner. I don't know which agent the identity owner happens to be at right now. So I need to be able to encrypt it in generic terms for the leaf node on the communications hops. Meaning I want to be able to encrypt it for your domain without having to understand anything about your domain.
I have some ideas on that, but anyway.
Yeah, that's interesting. I've been told, I don't know, when I first raised that one, I got a strong, no, we don't ever want to do that type. And I'm definitely getting the feeling more recently that that is a pretty viable use case. But to me, that should be up to the implementation to decide whether they think that's a good enough way to do it or not.
Well, and I would say it's not that we don't ever want to do it, it's that we don't ever want to do it in a way that creates key copying or mandates.
Yeah, absolutely.
Trust in your agent.
Yeah. Yeah.
So it's not that we don't want it, it's that we know it's hard and we don't want to do it unless we can do the hard work to make it work right.
Yeah. Fair enough.
Okay, so I want to, as much as possible, keep this discussion centered on LibVCX as it is now, and maybe the short term that is short term would include the reference cloud agent and reference edge agent that are being worked on, and hopefully get people's questions about LibVCX in that context answered. And specifically, if there are questions about the code and its structure and things of that nature, then hopefully those questions can get addressed on this call. So going back, like I said, there isn't necessarily an agenda. It was just kind of this is the high-level goal of LibVCX. If it is useful to people, I can share my screen and we can look at the source code if that is something that people are interested in seeing. maybe not.
I saw it a lot of times, so maybe someone else interested. Maybe you can just show us a Faber Ellis example, and we can just.
Yeah, okay. Let me get a terminal ready with that. Okay, I hear a complaint often that my terminal font is too small. How does this look?
It's good.
We can see it just fine.
Okay. Let's see. Let me make sure I've got this ready. All right, so what we have, this is a token-enabled demonstration between Alice and Faber. There really isn't much here regarding the token. You can probably just, for the most part, ignore that. It works with the libnullpay, which is also part of the Indy SDK, but in this case, it's also using libsoft token. So let's just look first at what we have in the Faber script. Let's see. First, it's grabbing what it needs from the VCX Python API, and then here it is creating a configuration that it's going to be sending, or that it's going to be using. So LibVCX, one of the first things you do with LibVCX is, as you'll see from this, is you provision an agent. Now, this isn't something that necessarily will be part of the this is something that I would say is specific to the Evernym agencies, but its counterpart, or not its counterpart, but the same thing will be done with the open source agents. So right here, we're telling it how to speak to its agency. Here is the URL for the agency's DID, and the agency's VER key. So an obvious enhancement that could be done here is using a did-doc for something like this. And then also
sorry, is this agency, or it is DID and VER key of supplementary cloud agent that should be different for each, for example, agent?
This is the agency's DID and VER key, not the agent's.
Is there a reason we're configuring these all as a collective and not looking them up based on the DID document or the attributes on the ledger?
Is there a reason? No, not necessarily. This was just the way it was initially designed.
Yeah, but I believe.
But this is an agency URL and DID, and not a particular agent. This would be the cloud agency that LibVCX uses to communicate with other agencies and agents. Slava, were you going to say something and I interrupted?
I believe for now it's impossible to use VCX without agency DID publish it on the ledger. So I believe we should have the way to be out of ledger if you want.
So these DIDs and VER keys are not on the ledger. These are not these. Yeah, this is just the way that it was explained to me. And I am just a lowly LibVCX developer. Is that this agency would be something that is set up beforehand, and for example, let's say Evernym sets up an agency that enterprises can then use when they stand up their instances of LibVCX. So in that situation, the agency's URL and the DID are provided to this enterprise who can then use them. They are not looking them up off of the ledger. So with this information, we call this VCX agent provision. So what this does is this will go to the agency and provision a cloud agent within the agency. It will also create and initialize a wallet using libIndy, and it will encrypt the wallet using the key here, and it will create a DID using the seed here, and put that all in the wallet, the Favor wallet. So this first call, VCX agent provision, goes out there, creates the agent, creates the wallet, creates the DID and puts it in the wallet, and the keys associated with that DID, and puts it all in the wallet, and gets the wallet ready for credential exchange. So the output of this VCX agent provision is a set of configuration entities or values that are then used to initialize VCX. So before you can do any call besides this VCX agent provision, you have to call VCX init. Now there's two ways of doing that. You can call VCX init with config, which just takes the configuration that was the output here, replacing a few things here like institution name and logo, things that go across in the credential exchange, and also pointing the path to the Genesis transactions of the ledger. So with that and some additional outputs that come from the VCX agent provision, so you get the output from the VCX agent provision, you add these three entries, and then you call VCX init. So this script is basically kind of a start from scratch script. There are other scripts that can be written here where you only run this call once, the VCX agent provision, you grab the output of it and you save it to a file, and then you would just call VCX init and you would point it to the file, and you wouldn't have to provision an agent every time you run the script. So at that point we have initialized VCX, and we are ready to start doing things with it. We've told it where its agent is, we've told it where its wallet is, we've told it where what its identity is, meaning its enterprise seed and the DIDs. And so now VCX, you can do a whole bunch of different things with VCX without having to specify those things again. This mint tokens here is only valid basically when you are using the Docker instance of a libIndy, or an Indy node Docker instance. This won't work on any other ledger. It'll just error out. But here we're going to basically put some tokens in our wallet, verify that we have those tokens, because in this instance we are going to be creating some schemas and some credential definitions, and in some use cases those will require paying some fees. So here, once we have initialized VCX init with config, then we go and we're going to say, okay, let's create a schema. So here we're creating a very simple schema that just has three attributes: name, date, and degree. So we just call schema create, and that returns a schema object. And then from there you can call like schema.get schema ID, and that returns the schema ID. So that will create a schema on the ledger. Then we're going to create a credential definition on the ledger based on that schema that was just created. So we call credential def.create, And then we have creddef.getCreddefID. We're going to store off that creddefID in a variable. At this point, we are going to create a connection to Alice and print out the invitation details. So when we run these, there's two scripts, the Alice and the Faber. This is going to output some invite details, which the other script will then consume to create the connection. So here we just call connection.create and Alice. And there are other things that can be done here. Well, not at this point. So the next thing we do is we say, okay, I've created this connection for Alice. Now I want to connect to Alice. You can optionally put in a phone number here, and a text message will be sent to the device with the invitation details. But in this example, we are not putting in a phone number. We're putting in none, and then we're just going to get the invite details and print them out and copy and paste them from one script to the next. This also could be accomplished with a QR code and I don't know, some other mechanism. But in this case, we're just going to output it, and this script will output it, and it will be the input to the other script. So we call connect, and then we call update state. So you'll see this pattern here where we update this, we call basically update state in a loop, and that is going out and it is polling our agent, our cloud agent within the agency, the cloud agency, and seeing if, for example, the connection has been accepted. So here we print out the details, then we get the state, and while the state is not accepted, we just loop and say, okay, update the state and grab me the state to see if it has been accepted. Now you'll notice here that this says step number 6, and then we jump to step number 12. The reason why is because you can see here it's just giving some simple instructions saying start the Alice script now. So the Alice script is going to do steps 7, 8, 9, 10, and 11. But for now, we're just going to move on and say, okay, let's say we sent out this invitation to connect to Alice, and Alice has now accepted this connection. So at this point, we want to issue her a credential. So we call issuer credential create, and we give it this. Here we have these schema adders, again, name, date, and degree, and we're just saying, okay, Alice, this is the date, and the degree is in maths. So we create an issuer credential with those attributes, giving it the CredDefID that was output up here when we created our credential definition, giving it the schema adders, and then just some other thing. This is the price associated with the credential, but in this case, we're just setting it to 1, and that all gets handled. Then once we have created this issuer credential, we say, okay, send this offer to Alice. So this handles bundling up, this handles the various libindy calls of creating the offer, and then it takes the output from that, bundles it up using the protocol that's established between LibVCX and the agency, and sends it off to Alice so that she can then accept it or reject it. Then we get into this pattern once again where we want to update to see if Alice has accepted the offer and sent a corresponding credential request. So here we're just waiting for the state to change to request receive. Once, and you'll notice here that the steps go from 12, 13, 14, and we jump to 17. So 15 and 16 are going to be handled in the Alice script. So once Alice has sent the credential request, at this point we say, okay, now send the credential over to Alice. So that's what that does. And we wait for Alice to accept the credential. Now we're going to do some proof. We're going to this is just going to really quickly and easily say, okay, now prove to me that what I just got you. So here we're saying, okay, I want to create a proof around name, date, and degree. And these restrictions are optional, but here we're saying, I just want it to be the same one that I issued. So we're putting in here the institution ID that was generated when we provisioned this script. And we're going to call proof create, and we're going to give it these 3 attributes that we're requesting. And then we're saying, okay, request the proof from Alice. At that point, we wait for Alice. We can see here 19, 20, and 21 are creating the proof and sending the proof request. And now we're waiting for the Alice script to gather the proof, get the proof request, go to the wallet and gather the credentials from the wallet and build up a proof and send it back to Faber. So once we can see that the state has changed where we have received it, then we call get the proof that was sent from Alice and check to see if it is verified. So this will go through and it will call the libindy calls to verify the proof. And if it succeeds, then the proof is verified. If not, then the proof is not verified. And there's a little frowny face there. Then we couldn't verify the proof. So any questions on the Faber side?
That walkthrough seems solid, Doug.
Thanks, Mark. Mark's another LibVCX developer. He's giving me some moral support here. Any questions? No? Okay. We're going to jump over to Alice. So Alice, the first few steps are going to look very similar to the other side, or to the Faber side, where we provision a cloud agent and we create a wallet, and we put, there's no reason that I'm using the same seed here. It's probably just kind of a copy and paste thing, but this could be completely different. Could be a completely different seed. Anyway, we're also, so here we initialize VCX to see we're doing a mint token seed, and that's just so that I can pay for the credential when it comes in. So here, again, you can see steps here, 7, 8, 9, 10, and 11. So specifically on this side, we are going to, here we're going to accept, the input is going to be the invite details that were the output from the other script. So we grab those details, and this could be the equivalent to accepting or clicking on a text message, or it could be scanning a QR code if you're in person, something of that. But anyway, the invitation details are inputted, and we create a connection with details, and then we connect, and that's the same as saying I accept this connection. And from there we update the state, though we don't really aren't doing anything with that, and we move on. So
sorry, I have a question. You have, for example, here connection object, credential object, but does VCX provide any persistent, or I need to serialize and serialize and store these objects in my database? How it works?
yes, that you are right. So for every object that I've talked about, connection, issuer credential, proof, disclosed proof, all of these objects are, LibVCX has no persistence layer. It does not store any of these objects. What it does is any of these objects you can do a serialize and a deserialize call. So it is up to the application using LibVCX when it creates an object to serialize that object and deserialize it as needed.
But do we have any state on agency side? For example, when I check the state of credential if, for example, my application crash after I call get state when state was changed to accepted. So the next call will give us exactly the same connection result, or we will miss this.
No, so when you call update state, it will go and it will query the agency for messages related to that connection. And the connection is going to have things like in credential offers or credential requests. It's going to have basically the messages necessary to interpolate the correct state of the object. So if the application crashes and you start it back up again and deserialize the object and call update state, then you will get back the correct state.
But it will only work in case if agency stores the messages on agency side.
Yes, the messages are stored on inside my agent within the agency. My cloud agent is storing those messages.
But when edge agent received those messages, are being deleted or are available in a later
They are
time?
not being deleted, no.
Okay.
So, but when I receive the message, as I understand, for example, when I receive credential, it will be stored inside of my wallet.
Yes, that is correct.
And how we identify this credential?
I don't think I understand your question.
We
It
have
is identified by the credential object that is serialized.
But what actually is included to identification part of this object?
So you serialize and deserialize. That is kind of up to the application what they want to name the credential. So they can give it their own identifier, and they should actually give it their own identifier. And then that's how they will store it in their database, and that will be its identity. Does that answer the question? So here, for example, when I call credential create, right here, I'm giving it this name credential. That's a very simplistic. You would probably give it some kind of a UUID here rather than just credential, but you would give it some kind of UUID, and that's how you would create it. And then that's how you would store it in your database. Okay.
Okay, but can I find, for example, connection object? For example, I want to find all connection for correspondent credential to understand who is issuer of this credential.
Say that again.
So I have credential in my database, and I want to find who is issuer of this credential. So as I understand, can VCX help with this, or I should store this relationship in my database?
The relationship is stored in the object itself. So when you serialize and deserialize, that is part of what is serialized.
But can I deserialize credential and get connection object from this deserialized?
No, you cannot. You would have to store both of them in your database, your connection object and your credential object.
But how I can...
Sorry. It does give you the connection DIDs associated with the credential, right?
Well, I mean, those are the connection DID is part of the
credential object.
It's part of the credential object, but the connection object itself is not part of the credential. The connection object itself is not part of the credential object.
But is there any interface to get credential DID from credential object without passing serialized JSON?
So right now, I don't think there is, but that is something that could be added quite easily.
Okay, one additional question. Usually when Alice sends credential request to Fiber, it should provide some data. For example, when I go for the passport, usually I should provide my name, my birthday, and some kind like this. But in this workflow, all fields should be issued or filled before any interaction with, for example, Fiber creates issued credential object, and Fiber should fill all fields in this credential before any interaction with Alice. And but I believe in real life, Alice should provide some data to the Fiber before filling of credential fields. And it's why credential request here. So credential request is not just only about providing blinded master secret, but also by providing some data from Alice side that can be verified on Fiber side. And only after this, Fiber should perform issuance of credential. And I believe...
So that is a valid use case, but it is not a use case that LibVCX at this point in time was meant to handle. It was not part of the use cases. So the use cases here were that, for example, LibVCX is going to be put into, let's say it's an institution like a bank or a credit union or something like that. So that bank and that credit union already have that information. And they are going to send that information to you in the form of a credential. So the use case was that this allows institutions to use the information that they already have and to send it to you in a credential format.
Just another reminder here, we don't call it the master secret anymore. We call it the link secret because especially when we start having multiple agents in delegation, the nature of a master secret no longer exists the same as previously.
Okay, thanks for notice. One additional question. Could you open Fiber example?
Yes.
And on what exact time issuance of credential will be performed? When we call
So I believe
send credential.
Send credentials. So in order to actually create the credential, I think you need to have received the request. So I think that's one of the inputs that is needed to the underlying libindy call. Is that correct?
Yes, because it should like some changes in the workflow of canonical and uncreds protocol. So we create credential before receiving of request. So, and I believe we have to issue it in send credential, and it can be a bit confused of the user, especially if user is experienced with libindy.
Okay, that's good feedback. Yeah, maybe that call gets the name of it gets changed a bit. But yes, it does get created in the send credential call. Okay, so any other questions?
Yeah, I guess I'm just a little confused here too. Forgive me for jumping a little late, Matthew here. Why is Alice creating the credential again? I thought, is Faber creating the credential?
She's creating a credential object. So what's happening is this is an object that is being used to handle the protocol exchange where she, for example, receives a credential offer, sends a credential request, and then accepts the final credential. So the final resting state of this credential will include the credential, but the functionality of sending or receiving the offer, sending the request is all bundled up inside of this object called the credential object.
Got it. Okay, I see. That makes more sense. So the credential object is doing the request from the offer, and she's going to receive that actual credential back.
Yes, and it will be, when she receives it back, it will be encapsulated within this credential.
Got it. Okay.
There's some people talking. Let me know if that gets disruptive. Okay, so here she's accepting the connection, and then she is waiting. She is making a call to her agency and to her agent within the agency, saying, "Let me know if this connection has sent me any offers." There are other ways of doing this, but this is the simplest. You can also just say, "Give me my messages." Give me any of my missed messages, or any messages that are unread on my agent. But that's not the way that these scripts are set up. But that functionality is available. So here it gets the offers, and then from the first offers is going to be an array. But in this simplified use case, there's really only one there. Then it will create the credential from that offer, and then it will send the request. And then it will wait to, at this point, wait for the credential from hold on one second.
Sorry, can I interrupt you a bit? But what if I have 1,000 of connections on my local wallet? Should I call get offers 1,000 times? For example, I have Edge agent, maybe a mobile application, and I have, for example, 1,000 of connections in this mobile application. And to receive offers, I believe I will need to call get offers call 1,000 times, and most probably it will cause 1,000 interactions with.
Like I said, there are other ways of doing this in the API. I just don't have them in this example. One of those is you can call out to your agent and say, give me any of my missed messages from any of my connections. So that it would actually just be one call that you make. And I can't remember exactly what that call is. It's, yeah, but there is one call that you can make saying, give me any of my missed messages.
And how I can understand that it is credential offer, for example, and that it is for specific
messages. The messages that you get back, because you have basically all the keys to decrypt these, then when you make that API call, it will come back and it will tell you what the message is. It will say whether it's a credential. If it's a credential offer, it will tell you who it's from. If it is a proof request, it will tell you who it's from. And all that information comes back inside the messages.
And so were you referring to the VCX messages download API?
Yes.
Yeah, and you have all those specifications to narrow down the search of which messages you want to receive.
Yes. So it's the download messages API call, and you can specify whether you want it against a particular connection or all connections, and you can give it message status, and I think those are the two things that it.
Or a subset of connections.
Yes, you can give it a list too. That's right. So yeah, that eliminates the need to call credential get offers for each connection that you have.
Thank you.
Okay, so we've received the credential offer. We send the request, and then we wait for the credential. And like it says, pull agency and accept credential offer from favor. So here, the update state will accept the credential and store it in the wallet. So now we're going to, again, pull the agency for proof requests. And the same, as we were just explaining with the download messages, the same thing can be done here. But in this case, we are just simply saying we are doing a specific pull against our agent to see if this particular connection has sent any proof requests. And in this case, it has. So we get the first one, and we call this proof get creds. And what this does is this will return all of the credentials in my wallet that can satisfy this particular proof request. At this point, it's up to the application to decide which credentials they want to use to satisfy this proof request. But since this is a very simplified use case, I'm just going to use the first credential that satisfies the proof request. So I build up this credentials, and then I call generate proof. That generates the proof, and then I send the proof back to Faber. And then Faber, again, will receive it and verify it. So that's a quick run through of the API, what it looks like. Are there any?
The question, when I get, for example, proof, usually I need to analyze what this proof includes, what credential issues is includes. And for example, it can be valid proof, but from issuers that I don't trust for this. And can I, for example, show this interface, how I can get information, what is included to this proof?
So when you call the get proof, this proof, let's see, on this side here, the proof here, you can, inside of that object, I believe it has all of that information. Everything that was provided by the proof, you can see in this proof request object. And then at that point, it would be up to, if the agency wanted to restrict the credentials or the issuers that it would accept as valid credentials, then it would put that in the proof request. If it only wants it from, if it only wants credentials from particular issuers, it would put that here in the proof request saying, I want that, I only want proof from these credentials, from these specific issuers. But all of that information, everything that is provided by the prover is displayed. You can get that off of the object here, the proof object. So then, yeah, a user interface could display it, and it would say, you know, what this credential came, who this credential came from, anything that's provided by LibVCX display here for them to analyze.
Okay.
So if there are suggestions, then we definitely want to hear them, and probably the Rocket Chat would be the best place to put those.
What's the Rocket Chat channel for the VCX? Is it just the Indy SDK one?
For now, yes, it is part of, since LibVCX is now part of Indy SDK, then it would be part of the Indy SDK Rocket Chat channel.
So will this be able to function without any of the token code, or is this require token code in order to run?
So this can use libnullpay. It does require token. It does have a dependency on token-related functionality, but that can be provided either via libnullpay and or the SOV token library. However, that being said, on the favor side of this, you can, let's see, where is it? Right here, when you create this issuer credential, this last parameter here is the number of tokens that you are charging if you wanted to do for example, let's call it a premium credential. Or in other words, I'm about to give this person or offer this credential, but they have to pay for it. So you could easily just put 0 here as the price. And if the price is 0, then there's no need for payment or anything like that. So while there is a token, I hesitate to call it a dependency, because, like I said, you can use libnullpay, or you can use any of the libraries that libindy supports for token-related functionality. You can also basically set the prices down to 0, so that the token-related functionality basically becomes a no-op.
But I believe for now, VCX forces usage of single-user payment addresses for payment verification. And it can be incompatible with, for example, payments made by Visa or MasterCard. Yeah.
Yes, that's correct. So if you were going to do something through Visa or MasterCard, then you wouldn't want to use the token. Good question. Any other question? I know we're over time, but I'm happy to stay on and answer any questions that people have.
Since we are already out of time and no question, so.
Okay, then I think we will end it. Thanks, everyone. We'll see you on Rocket Chat. And again, thank you, Stephen, for recording this session. That was greatly appreciated.
No problem. I'll make this. I'll work with Richard to get this published.
Okay. Thanks, everyone.
Thanks, Doug.
Yeah.
Thanks, Doug.